Good evening, everyone. This is Cameron Presley and Reid Evans and Emily up here at FunctionalKnox, and we're about to get underway for Reid's presentation on getting started with functional programming in F#. Just a couple of housekeeping notes here. Love to go ahead and thank the Windsor-Essex.NET user group for coming up with the idea. Derek Martin kind of reached out to Reid to do this really cool presentation, and I think in return, next March, first Tuesday of the month, Derek will be repaying the favor, talking about, I think, fat controllers and slim diet, correct? It's same time, same place. Also, thanks Tech Systems for providing the venue for the meetup. And I believe that's it. Reid, is there anything else we need to mention? Good to go? All right. Well, with that, I'll present Reid Evans.
All right, hey everyone. So this is getting started with functional programming in F#. Usually I start with jokes and stuff. There's not enough people in our room for a whole lot of humor to hit very hard. So I may not do that. All right, cool, we're up and running. So getting started with functional programming in F#. I've been doing functional programming now for I don't know, a couple years, and by doing functional programming, I mean learning, just like with anything else. It just takes time to learn stuff. What we're going to do today is we're going to look at actually building an application. Switch to my screen here. We're going to build a locations application, so basically we're going to take something that's very trivial from a domain perspective and have it as locations. So we've got concepts like city and state. And then we're going to be able to add a location. We'll say Windsor, and you just work with me on state versus province. Then we can add it. You can see here, we can go in, we can delete that location, and all of that works. We can also get a specific location. So it's real trivial, kind of like a to-do MVC kind of thing, only we're not going to use MVC. We're going to use, actually this is all built in a framework all within F# called Suave, which you can find at suave.io. But that's not really important for what I want to go through today. As I go through, and I'll start real quick here, but some of the takeaways. In an hour, I can't teach you how to do anything, but hopefully what I can do is kind of inspire you to go learn more on your own. So the takeaways, especially with the language, the language's defaults matter a lot. Type providers are awesome. And I gave you double equals here. F# just has a single equals, which we'll get into, but there's no more null. And then basically composing small functions together to build something that's a bit larger than the sum of its parts. So those are the big takeaways of why we would want to do that, and hopefully we can show you what we get with the app from being able to do all of those kind of things. So what I need to do now is to go back a little bit. And so what we're going to talk about first. So here is our program. This is, as we said, this is F#. So some of the syntax is a little different from what you might be used to. Lots of spaces. There's very few semicolons or semicolons. It is valid in the language, but you probably are never going to use it. And very few curly braces. So what we have here, we're going to define our model first. And in this case, it's a type location. So location is the name of the type. And then you can see that it has three properties: ID, city, and state. ID being an integer, city and state being strings, and those are the exact same things. Those are just pulled from the .NET framework itself. So this kind of will create a type for you. Think of similar to a class, except that F#'s functional first. And some of the things that we have with it being functional first is this type is immutable, which means if once we've created it, we can't modify any properties in here. So if I had a location value that I had created, I cannot update its ID to be something else. What I could do is create a copy of that location and set the new ID equal to something else. But I couldn't actually modify something that was in there. That's not the default. There are ways to do it within the language, but it's not the default, and that goes back to the whole concept of your defaults mattering. So one of the other things that this gives you is, because everything here is immutable, you also get free pretty printing. So it will automatically know how to print itself out to a console. And you also get equality by default. So you don't have to override all the stuff with the equalities like you would have to do with the .NET framework. And if you think about it, if everything is immutable, then equality becomes really, really easy. Because one of the reasons that equality gets difficult is because things can change over time. And what you've done is you've complected what your state is with time. And when you do that, it becomes very difficult unless you're looking at like the DNA level. So my example for this is always a version of me when I was 3 is going to be difficult for you to tell if I'm the same person that I am now, because this data has mutated over time. Unless you were doing some sort of, unless you had the whole DNA chain, right, the genome project happening there. But if you were looking at the DNA and the stuff that does not change, then it would be very easy to just say, ah, yeah, these things equal. And so what F# is going to do for you for the equality is it's going to say, hey, if the ID matches the ID, the city matches the city, the state matches the state, then we're all good. And because, and so that's some of the freebie stuff that you get, all for, you know, what do we have, 5 lines of code here with our location. And then all of this stuff down here, I'll just say a quick note about it. This is just Suave starting us up. So you'll see start web server and basically default config and then our app here. I'm not going to go into this much at all. It's much more the framework that I've chosen to write with here than really the domain of what we're trying to do. If you are interested in it, it's a purely functional way to write code that's much more like a node. It's very, very lightweight. MVC or something like that. So now once we have our model defined, one of the things that we'll want to do in all good .NET applications, we talk to a SQL Server database. So check out -A, huh? No?
I think you misspelled the type provider branch.
Yeah, I think I did too. I was trying to see where the L. All right, and we're back. Okay, so you'll see that some stuff has changed on the screen here, basically just so that you all don't have to watch me type any more than you just did, and apologies for that. I'm just going through get tags, and all of this, I'll post a link to all of this code, GitHub. So we've got our module name, which is kind of like a namespace, the same thing that we had before. We've got a bunch of opens. This is like the using statement, or this version of the using statement in C# because it's overloaded. We've got a literal here, which is just the database connection. Yes, I could have put that in a thing or an app config or whatever, but just so that it's all on the screen. Here's our location type from earlier, completely unmodified. And then the rest of what we have down here is what we want to talk about in this section. So in this case, you see this location card. This is, once again, this is like a virtual DOM kind of thing for a way to actually display a location. This, once again, is framework specific, so I'm not really going to spend a whole lot of time talking about that, because the more important part for this section goes to the use of type providers. So what do we have here? Here's the function that I want to talk about, locations, and I'll zoom in here a little bit. I don't know how big that is on everyone else's screen. So we have get all locations. So get all locations is a function. Everything that you do in F# is going to be prefixed with the let keyword. and I'm not really going to go over too much of the syntax, but just to say, what we're saying is we're saying we have a get all locations function. And this little thing here is called unit, but it's basically a way for me to allow this to be able to run as a function rather than being set to a property. And that's, if you decide you want to play around with F# some more, that will all make sense very quickly. So the big thing that I've got here is I've got this line here where we're saying use this new SQL command provider. And so we're saying use query equals.
Hey, Reid, somebody asked if you could zoom or do a bigger font.
Bigger font? I sure can. Yep. Thank you. Yeah, if you can do it online, I've got Cody Lambert here of Knox Devs who is helping me out here with questions get answered and stuff. So definitely do that. You can tweet. Who do we want to tweet you?
At FunctionalKnox.
Oh yeah, at FunctionalKnox. That works great. And then we'll have someone else manning that too. So so that hopefully we can get any questions answered as we go. So yeah, hopefully that's better with the font there. So what are we doing here? Well, obviously we've got some inline SQL. Select star from locations, and we're passing in that data, that DB. The DB, if we remember, is just our connection string. We're saying query execute, and we've got some other stuff here. Like, what is so neat about that? Because what I said at the beginning was that type providers were awesome. Well, let's say that I mistyped locations. Our code no longer compiles because of the type provider. So what the type provider is doing, in this case, this is a SQL command type provider, oddly enough, because it's so named here. But what it's doing is pre-compile. It's actually going out and getting the metadata that would be returned from issuing this query on our database that we passed in. And it's able to validate whether or not this is correct. So I don't know if you can see it on the screen here, but it's basically saying invalid object name locations because typoed locations. So this completely saves you an integration step. So if I type it in correctly, then you see that it's perfectly fine now because it's went out to my database, validated that this query can be executed. And if that query can be executed, then the code, then we will be able to finish doing a compile step. To it's not really similar to. It's a similar concept to Entity Framework with the code first or a generate classes from your data model. But in this case, that are created, these types that are created are not in our project. We don't have to manage them. If the database changes and we rebuild this thing, then it's going to automatically update and we'll have to manage that. So there's none of this translation or whatever to happen there. There's lots of these different type providers. So there's for basically any kind of data access that you'd want to do. Anything that is at all structured, basically there's a type provider for that. And so this is used. So this is used. This is like the other using keyword in C#, which disposes of resources for us. So basically what we're going to do is we're going to say query execute, and then we have a sequence.map function here. So sequence.map, if you're used to the .NET framework and link at all, sequence map is the same thing basically. It's just that most other languages call that type signature map, and C# chose to go with select to make it more like SQL, I suppose. So what we're doing here is we're going to select all the locations, and we're going to execute that. And what execute's going to do, if we hover over it here, it's going to return an IEnumerable of some type. And what we want to do is we want to return a location of this location rather than a list of some generated type that was created by this type provider. Now you could absolutely continue and pass that around, but this is kind of a way of encapsulating your data model from, it's a way of throughout the rest of the app we can deal with our location, which is in our domain, rather than dealing with the SQL types that were auto-generated for us. Here is sequence map, and just because that is a lot of syntax on one line, this would be the same thing as saying, if we were in C#, is saying, new location, x.id, x.city, x.state, right? So it's the very same thing that we're doing here. It's just this is the F# syntax for it. This is the C# syntax for it. Exact same thing. But another thing that you'll notice is that the type provider did a lot more than just validated that that was OK SQL. Because what we also have, if I were to say X, I actually get IntelliSense on what properties or what fields are actually on that table or returned from this query. So I can say ID equals ID, and further, it knows that that ID is an integer because in the database, it's an integer. Is a string because it's some sort of varchar in the database, and the same thing with state. We can validate this further by saying select city, state from locations. Now what we find is that, and it is case sensitive, now what we find is that our code is fine here, but the problem is the type returned here, this X, this record now, doesn't have an ID property because we're not returning an ID property from database. So just so that we see that I'm not cheating at all, we add ID back into our list of properties that is going to be, or fields that are returned from this table, and all of a sudden our code works. So this is a really cool thing. And again, I'm just showing the SQL version of this, but there are type providers for HTML, JSON, XAML, and a host of other things, really. Anything that's structured data, basically, there's a different type provider for that, and you can write your own. There's ways for sure that you can write your own. Most of these are community driven. In fact, most of the F# is community driven. So let's see. So now we can get all locations, and that's our display locations. We're not going to worry about any of that. So that'll allow us to get all locations. And if you see locations, basically I'm just calling that get locations function, and then I'm using map again to map that into a location card here, which basically just says it's just like selecting a virtual DOM thing, and then putting that in here. This again is mostly framework code, so you don't have to worry about that too much. The only other thing I'll say is about, before we move on to the next step here, is about this little guy here. So this is known as pipe forward. Basically, think of this as kind of like an extension method. If you're coming from C#, which I imagine most of the people listening are. But basically, query execute returns an IEnumerable. And what we can do then is instead of saying .select here, instead of saying .select here, we can actually do this funky character function to that character. So it's basically like doing an extension method. It's basically saying execute and then map over this stuff and then turn that into a list. And I turn it into a list here just so that there's no confusion over when it can get rid of the connection pool. Type providers for sure can save you a ton of time with integration testing or having to build or having to do anything else to validate that the code that you thought you were running against the database is actually what was running and the type matching. See here too is that in our getAllLocations function accepts unit, which is basically nothing, and it returns a location list now. And it knows that because we mapped into a location here. So it's statically typed, we just don't have to define those types. And we'll see that some more here in just a bit. So let's go to the oddly named All right, so now let's look at what we would have to do to get a singular location. So what we saw before was our getAllLocations. thing that we had before. I haven't modified that at all. Still displaying locations. But what we want to do is we want to get a location by the ID. So let's look here at what we would do. So once again, we've got another SQL command provider this time, and we're going to select star from locations where the ID equals, and we've got our parameter here. And then we're passing this additional thing here that says single row equals true. And when we execute that, what we're going to get option thing back. So before, if we look at our get all locations, we had to call the map function on the sequence module. In this case, we're returning an option from this because we said single row equals true. And so we see that query.execute, if we hover over it, returns an option of this record rather than an IEnumerable or a sequence of that record. And so we use option map there. But what is this option thing all about, right? In our takeaways, if we scroll back over here, is that your defaults matter, type providers are awesome, we already saw that, and no more null. So how do you deal with the fact that you can't have null if you're trying to get a specific item from a list of things that you don't know what are in that list? Well, the way that typically functional programming deals with this is a concept called maybe. In F# it's called option. But before we go into that, let's explain why that is and why coding this way makes a whole lot of sense. So if you see the screen here, we're going to go back to 7th grade math in the US. In Canada, this was probably in 3rd grade. The jokes don't get any better. So what we have is f of x equals 2x. And if you had a calculator like I did, and actually where I started coding, that probably looks familiar. So basically we're saying we have a function that when given an x will return 2 times that x. And so then you might have heard a concept called a domain and a codomain. Some people might call it a domain and a range. But basically, this is what a function is. So if in functional programming we're going to code with functions, then we need to have functions like this function. And by that I don't mean just numbers to numbers. We can have other cool types, which we've already seen with our location and everything. But what I mean by a function, an actual function, is that for every element that's in its domain, there's a valid value in the codomain. If you look at this function, every time I pass a 1 in, I'm going to get 2. Every time I pass a 2, I'm going to get a 4. And every time I pass a 3, I'll get a 6. And it doesn't matter how many times I call this function or whether someone else has called it, it's always going to produce the exact same thing. So a phrase you'll hear a lot is a concept called referential transparency or purity or pure function or total function. These are all going to the same idea that your function, in the signature of the function, it can tell you everything you need to know about how you need to deal with that function. Like f of x equals 2x here. If we try to pass a string, this is going to fail. But string is not in the domain of this, right? The domain of this is numbers to other numbers. You see here that 3 isn't represented. Well, that makes sense because this function is going to only give us even results. That's perfectly fine because that's in the codomain. So everything that's in the domain needs to be mapped to a codomain. So how can we do that though if we don't know, because if ID here being an integer, not all integers should probably be in the domain of the function that gets a location by an ID. So think about this as though we have an array. And this is like saying, give me the item at the first position of the array, array 0. You would have to first guarantee that there's something at 0, or what would happen is you would get some sort of a null reference exception, or you would get some other sort of error. In C#, the way this is dealt with is you would say whatever your list is, or your IEnumerable of T, whatever, and we're going to be able to say dot first or default is an example. And what does that return? Well, that returns either T or, right? But since we don't have null, we need some way to deal with that. And that's what this option thing is all about. And so option is actually defined. We don't have to define it, it's part of it, but it's option T, and we just need to tick there. So this is a generic. Say sum of T or none. And so basically that's what it is. So this is a sum type or a union type, or there's lots of different words for it. But basically it's an idea of saying this type can be constructed by calling, you can create an option of T by calling the sum function with a T, or you can just say none, which works a whole lot like nullable in C#. But if we go back to this concept of, on our takeaway, that your language's defaults matter and we don't have null, what does that give us? Why would I want to go through the hassle of having to introduce a new type and having to map over that and do all of this other new stuff that maybe I'm not used to, rather than just dealing with null? Well, the reason is that if everything in your language can be null, then you have to check for null everywhere. In this case, we're saying nothing in the language can be null. And the only time you would ever have to think that it might be null is when the result of the function says that it's returning something in this option type. So that's really neat. Now we don't have to wonder, did I forget to check for the null reference exception here, because first or default can return null and I should probably check for it, but nothing's forcing me to. In this case, we're saying you absolutely have to deal with the case when it's nothing. In this case, I'm using map just to map over it, because we've already seen map here. It's the same thing as, or I'm sorry, we saw it down here. Sorry, hope no one gets motion sickness there. So we saw it down here with the sequence. Is this thing that happens on all sorts of different types. Very, very easy to deal with. If you've dealt with promises at all in JavaScript, it's basically what then is about, although it's kind of a couple different things. It's what async await is partially about. But then basically we're doing almost the exact same thing where we're creating a new record of location. So you see that this thing returns in a location option. So any code that calls into our locations by ID is going to have to deal with the fact that try to return something, but it might not be able to. And what we see here in our route location by ID, where I'm actually calling that, I actually have to do this thing called a match with. So this is kind of, this is a pattern match. And it's very similar to a case statement or a switch statement in a lot of other languages. But you see, I have to provide a case for if it's none. I have to provide a case for if it's some. And don't really have to pay attention to the rest of this because it's, well, it's just, it's part of the framework stuff. But what I think is important to note is if I remove this, then I immediately am told you've got an incomplete pattern match on this expression. None may indicate a case not covered by the pattern. So basically the language is going to let you know that you have to deal with that in the match case. Maybe location is a location option. So I couldn't even try to say something like maybe location.id, right? It's not there. I have to explicitly destructure that or pattern match here into this local variable or value, I guess I should say. We have any questions online?
Not currently.
Okay, cool. Sorry, that's a lot of data. I go back to whether you understand exactly what we had to do there, you understand the benefit of being very explicit with what we're actually doing. I could have easily called this in a different way and told and lied to all of the callers of this code and said I will always return you a location, because the domain of integer is infinite. Well, infinite like, because we are constrained by the .NET framework. But we know that there are times where someone could pass in an ID that we don't have in the database. And what we're trying to do is to be very, very explicit about you, given the fact that we're saying that the user can pass in any integer possible into this function. This might be a good time to also highlight again, which I highlighted earlier, is that F# is a language that is statically typed, but you'll notice you don't see a whole lot of types anywhere, and that's once again because it's got type inference. So if I hover over ID there, you can see in the IDE here that it's telling me that that is an integer. So let's look into why that actually knows that that has to be an integer. So what we're going to do is, if we look at where ID is, we have ID here in our query execute, right? And we have an ID that we're passing in. So I haven't told anything about this, that this is an integer, but what the compiler is going to do for us is going to say, okay, where is that ID being used? And in this case, it's being used within query execute. Well, our type provider knows that I'm passing in this ID property, this ID parameter, into this query. And the predicate is going against the ID column of the locations table. And the ID column of the locations table is an integer. So to call execute, a user has to pass an integer. Hence, ID has to be an integer because I'm doing nothing to it from when I get it in to when it's here. So it's actually able to deduce all of that for you. Type systems have been able to do this for a long time.
30, 40 years.
30, 40 years. That's Emily here, who is another FunctionalKnox member who keeps track of such information a lot better than I do. So yeah, they've been able to do this for a long time, and this is why if you may hear people talk about F# having a strong type system or a better type system, and that sounds very pompous, but this is some of the things that people are talking about. F# is not the only language that can do that. There's lots of them that'll do that for you. Not many of the very popular mainstream languages do that for you. So let's see. So we definitely saw the null. So another thing that we can do that you may want to do in an actual real-world application is to go async. So in this concept right now, we're just query executing and we're returning this record. But if you want to scale, one of the things you might want to do is to make your code asynchronous. And so you can actually do that very, very easily in F#. F# has a concept of async, like which is kind of like task from C#. Only async came first and was only later ported to C# as task. So it's not that F# is trying to be difficult. C# was actually the one who tried to be difficult with task rather than using async. The libraries are slightly different, but basically it's going to be the same. So I'll show you here what it is on this on our get all locations. C#, this would look something like public async task of some t, get all locations, and then we would await, right? So we, this is kind of weird doing a no code help here, but equals await, go do some stuff. And so this is what it would look like. In F#, what we're going to do is we're going to wrap everything in this async. This is another one of the few times you're going to see curly braces in this language. We're going to wrap this whole thing in async. Instead of await, we're just going to do let bang. And so the bang is going to say, this async execute is going to return this really long, nasty, ugly thing. An async of a system collections generic IEnumerable of a SQL command provider here of a record of whatever is returned by that. But then if we look at what locations are, it helps us a little bit. It removes the async. So what we're doing is this is saying, go ahead and go do this. We're not going to block on the thread or anything. We're going to let anything else come in, and then we'll pick this back up when we get to it here, which is no different really than what C# was doing with the task. So our locations here are fine. Once again, like we had in the initial get all locations, we're going to need to map over that so that we get our location type, and then we'll turn it into a list. Another thing that you end up having here is this return keyword. And this return keyword is not return like return from this function, because everything's an expression in F#. This return basically says, okay, I've been dealing with locations as though it was an asynchronous, but so this function is going to have to return an asynchronous collection of this. So you see that get all locations takes a unit and returns an async location list. Basically just wraps the locations back up in this async so that we're not blocking, because otherwise we would actually have to block here. So now anything that calls get all locations will have to deal with the fact that that was an asynchronous computation, and you'll have to do something similar to this in calling code, which is very, very similar to what C# does with the async keyword with the task. So if you've noticed, well, all I wanted to do was make my database call asynchronous, but now everything all the way up the stack has to know about a task. It's the same thing here in F#. You can't really get away with that short of blocking or continuation passing, which is basically what we're doing here anyway. But that gets into some other functional concepts. So basically, that's it. So let bang equals await. Another thing I will note is that in C# this is syntactic sugar that the language designers in all of their wisdom bestowed upon us mortals so that we could actually write code this way. In F# you can actually create your own. These are called computation expressions. And actually I can show you some of that here. Actually, I'll show you some here next. So rather than only being able to deal with it with this task thing and having it being a compiler thing, we can actually write our own workflows, which is what a lot of people will call these, and allow us to do things like let bang. So, oh yeah, I actually did well and didn't save it that time. All right, so now what we're going to do is we're going to go in and we're going to start adding some business logic, because so far all we've done is like CRUD stuff. And what we really want to do, and this is where I think a lot of times people say, functional programming is great for data. Functional programming is great for data, but and statistics and math stuff. But I think it really shines when you're dealing with business logic. We also have delete locations here. So if we scroll down to our insert location, so we also saw that I could do, we could insert a location, and this insert location, once again, it's another type provider. I'm not going to go through that again. We all understand that they're awesome and see the fact that city and state both have to be strings. We're passing in a location record here, and we know that it has to be a location record because location is the only type that we have in scope of this module that has a city property and a state property that are both strings. So it's able to guess. If for whatever reason, we could give it a little help here, and that will happen from time to time. There are ways to be very specific about what you're doing. But so to insert a location, in this case, I want my data access to just say, yeah, whatever. You can insert the stuff. But there's some other things that we might want to do. So in this case, we have this function that gets the location from the form. So this is, once again, framework stuff where it doesn't provide a model binder by default. And you actually end up writing your own model binder for this. Specific thing, that's the thing with Suave. You can use F# with Web API and VC and get more of the magic stuff where it will automatically model bind stuff for you if you want to do that too. But so what we're doing here, we're saying get the location from the form. And so this is, we're going to see something very similar. So if we go back to our concept of having our domain and our codomain, and we take that same concept and apply it to getting something from a form post that came across the wire from some client. That form posts, not unlike people in masks, should not be trusted. I had a few chuckles in the room. I told you the jokes don't get any better. So we have, what we're doing here is, for every form post that comes in, are we able to guarantee that we can create a location from that? Absolutely not. So what we'll need to do is to provide something that says that this might not be valid. Now, I could use our option that we saw from earlier, and what we saw was that option was either, if we do T, is either some of whatever that type of T is, or it's none. This is get rather than having you all watch me type. So that's what we said that this was. But the problem is that it might be great to know, or to be able to tell the user why we're telling them that that wasn't valid. And so what we have is this other concept here of either. So if we look at either option here, just to compare and contrast, so we've got our type option, which is either some of whatever that generic is or none. There's this other concept of this data structure called either, and either is great. It's what is it that you always call it? Validation?
Yeah, validation result.
Yeah, like a validation result kind of thing. You may have seen it notated as. Another place where you would see this is if you've done any node. All the callbacks, you know, they take a function that the first argument is an error case and the second case is the success case. This is very, very similar. Same concept if you abstract the layers enough. And so this is really neat. So now we can provide really good error messages to the client. So in this case, our location from form is going to take some form. And as I said, this is all the frameworky stuff here. But then you see it's going to return in either a string, which is if it's a failure, or it's going to return a location. And if we go to our either, we see that stuff's either going to be a failure or a success. And we see that both of those are generic. We've got generic type parameters in here. And so if we can get a city and a state from the form post, then great success. We return a new location and ID -1 because we don't care about that at this point. But if we can't, this is kind of the catch-all default. We're saying, well, you know what, that's a failure, and we're going to return back that we could not create the location from the form. So what are some other things that so at that point now we're in our code and we have this either a string, which is an error message, or an actual location value we can work with now. So this is kind of our boundary code. So once we're in there, some of the things we might want to do is the state. So at the beginning I said that F# was immutable by default and you could not modify something. So this is a way that you, quote, modify it, is you actually create a new location and we just create that new location. It's a copy from the other, except that the state is the location, is the current location state to upper. So this would look something like bringing in the location, setting location equal to state to upper. It would look very similar. But this record update syntax makes actually dealing with that whole concept of immutability much, much nicer than it would be in a language that did not have that. So a way you can think about this is saying, give me a new record based off of the location value that came in, except that I want the state property of the new location that's created to match the location's, the previous location's state to upper. So if we look at the type signature for this, you see that it takes any location and it can guarantee that it can return another location because we're not doing anything else. Our domain and our codomain can be the same and we don't have to deal with any other kinds of types here. Is to say that the state has to be 2 characters. So once again, we're accepting a location. we're saying if the location state length is 2, then we're going to return a success of location. This is great with past validation. Else, we're going to return a failure. Something to note about if then else within F#, if is an expression, not a statement. That means that you are pretty much required to return to provide the else case unless you're doing something that's functional thing in the language. So unless you're doing some sort of side effect thing, you almost always have to provide then else. This could have also been written with a match with, but I was trying to kind of show that you still have some of the, it's not completely foreign, I guess is a way to say that. So we're still sticking with this concept of our success or our failure. And so if we look at the state as 2 characters, what would we expect the type of that to be? Well, we know that it accepts a location. What kind of, what type of data is it going to return? Well, it's going to return either a string, which is our failure case, explaining why it failed, or it's going to return a location. In this case, we're just passing the same location on, or we're letting the user know that there was a failure, and the state must be 2 characters. Another thing we might want is to say that none of the fields are blank. So once again, we're using we're using our string is null or white space from the .NET framework. And if either the city or the state is null or white space, then we have a failure, and we tell the user that both city and state are required. Else, we can return a success of a location. So you see that no fields blank has the exact same signature as state is 2 characters. They both accept the location, but they can't both guarantee that they'll return a location, because if the state is not 2 characters, in this case, it's a failure of some sort. If one of those things is null or white space, then there's a failure. We have all of these tiny little functions. And once again, I'll go back here to our takeaways, talking about composing small functions. Because all of those little functions are great. They're easy to test. Very, very easy to test, right? I mean, from a testing perspective, how easy would it be to validate this capitalized state? It would be almost so trivial that it would not be worth it. Similar thing to this, your test is going to have almost all the logic that any of these actual functions have. So then you're basically using your tests in this case as a regression suite or whatever. Which is totally something you can do. Another thing that you can do is actually generate tests, which we should have. I think we may have a talk coming up about that here, hopefully pretty soon at FunctionalKnox. So to combine all of this stuff together, though, one of the things, so I'm providing both, and it just barely fits on my screen here. So there are 2 different ways that we can combine all this stuff. And what I've got here, I've got it in 2 different ways. The code, this code, exactly the same code as this code. Produces it's not the same code. It produces the exact same result. And I'm just showing both of them here because some people, it depends on what your perspective is as to which one makes more sense. I find that most people who are not used to the F# syntax, they like this better. We have curly braces. We are saying, we're explicitly calling out what each of these things are from form, no blank fields. We're setting stuff to values, and it looks much more like imperative code. And as soon as you start looking at or getting used to functional code, or if you've done anything with a Unix shell, this makes a whole lot more sense. So they both do the same thing. Neither one's better. They both create the exact same thing, but it does show 2 things. One is that, you know, I mentioned you could create your own workflows, and that's exactly what we've done here. This either is actually defined over here in our either module, and I can show that here in a bit, but you can absolutely do that. And in this case, we're saying let bang. So if we take our locations from form, which we know might not be able to return a location, and we call it within our either workflow and say let bang, then from form is a location. Is if this can't return a location, it's going to short circuit and not do anything else in this whole pipeline, which is great because then it's going to return to the user whatever the error message was from location from form. Let's say that location from form passes, but they left some field blank. Well, in that case then, this no field's blank also thinks it should be a location because we've got let bang. And what will end up happening is the error message from our no fields blank will get returned to the user, and so on and so forth. That's exactly the same thing we're doing right here. Up top here, we're saying, given a location, we're going to pipe that into location from form. Once we've done that, we have our concept of this either. It's either a string, which is an error message, or it's a location. No field is blank doesn't know about that concept. It thinks you're going to pass a location. So a way to deal with that is to call the bind, is to pass that function into the bind function. This is the same thing as select many, basically, in C#. Or you may have known it as flat map, or you may have never heard of it before, and it may be confusing to you, and that's okay. If you work with this at all for just a little bit, it'll all make sense. This is absolutely understandable. No magic here. It's just basically a way of making sure that our types match up. And it's got this really nasty, ugly type signature. Map, we've already seen map on the sequence. We've already seen map on the option. Here it is for either. And let's just look into those for a bit just so you can see kind of what that looks like. So map on the either, we've got a map function that takes a mapping, which is a function from some type to some other type. They could be the same types. This would be like from a T to a U in a C# parlance. And then we're accepting some sort of an either. And we're saying we're matching on that. It's either a failure or a success. If a success, then take whatever the value that was in the success and call our mapping function on it, and then pass it back. With a bind, the function that we actually pass in is going to return one of our eithers, so we don't have to wrap that in a success. Over your head, no big deal. I just wanted to show that this is very, very little code here to be able to implement. This is a very, very low-level comp sci programming language kind of thing that is very, very well-defined, not just in the programming language or programming theory, but in math and other concepts well beyond that. I also showed here that we had that our workflow. Basically, to be a workflow, to be able to do this sort of stuff and be able to use this let bang stuff and write code as though it looks imperative, but is actually composing pure functions together. A type either builder, and this is actually creating like a legit class on the .NET framework. And you have to provide a bind function and a return function. And actually, in this case, these are methods because it's associating it with this. Basically, it's just calling my bind and my and a success function here, which is the return, which I said just wraps the thing up. Anyway, and we just call one of these. So this is all the code that it took to be able to write code that is purely functional, have all of our types match up, but still have the code look imperative like you would see in most other programming languages that don't necessarily have some functional concepts. So your code ends up getting the benefits this way of being functional, but it also then is readable to people who may not be familiar with concepts like map, bind, etc. Those things get pulled up, and that's really it. You see here at the end of this, we get an either to route our result. And once again, this is framework specific stuff. So what we should be able to do now, unless I completely botched something, to run our app, and we go back and we'll see some more of it. So we saw this before. If we want to add a location and we don't pass state and state are both required. Well, that tells us is that the no field is blank condition must have messed up because that's the failure city. And so if we see that no field is blank, we see that if we go to our creation function, we know that we got the look fine. Nothing was wrong with that, but no field is blank failed. So we never tried to check whether the state was 2 characters, and we state, and we most certainly don't insert it into the database, which we can see if we were to go back to have a blank location inserted in here. Another thing we could do is try to put junk data in here. And now it's saying state must be 2 characters. So now we got past that other one, but we failed here. If we go back to our locations, once again, we would not have that in the database. Did I mind trick? Put the slash. But if we were to go in, as we saw earlier, and add that location, then everything matched. We were able to throw it in the database, and now we have a new record here, which we can go on. We can look at the specific ID for it here. But then at that point, everything's. I guess just for clarity's sake, let's add Essex too, right? That's another place up there in the north. This is as close right here. Detroit is as close as I've been. I was gonna swing over, and the bridge told me that I would not be able to re-enter the country. There was no turning back where I had to take that bridge. So I kept going. So you see that this stuff kind of works. The big takeaways here for me, is not that you understood all of the syntax that I showed, or you understand the entirety of the F# language. What I hope we showed was the fact that the language's defaults matter. The defaults of immutability make things like equality very easy. The fact that nothing can be null by default makes a huge, huge difference. Because then you only have to deal with the concept that something can't be there, option type, or that either type or something. But regardless, the type system is going to tell you that and force you to do that. Type providers, if we remember them, are pretty awesome. They remove a whole bunch of stuff. I will say they increase your compile time, obviously, because it's doing external checks. But there's a whole host of other things that you end up catching, really, with most modern editors, rather than having to, run the app and then see the thing fail or run some sort of integration test. And then we showed how if you were to compose a lot of small functions together, that becomes very, very easy in this language. Whether you want to do it pipelining them like this, think of this as though it were just extension methods. So it could be like, instead of an either, let's say this was some list of things. Well, within C# you would have locations from form or whatever. You'd say .select many instead of bind, and you would say .select many instead of this bind, and then instead of map you would say .select, and it would be the exact same thing. So it's not that you can't do some of this stuff in C#, and in fact, with the next version of C#, even more stuff from F# is going to get ported over. But basically, by using F#, some of those features that are going to be coming down the road for C# you can use right now. And some of the things like being able to provide these computation expressions, I don't know that they'll ever get. And I also don't know that they're ever going to get command providers. They're most certainly, C# is never going to get null not allowed by default. There's absolutely no way to do that without absolutely destroying all the backwards compatibility. So those are some reasons why maybe you should continue looking at F#. Or other function languages. If you're brand new to it, I think Elm's also another great place to start, because you don't run into the issue of having runtime in a framework that's very impure. Everything within Elm forces you to be pure, and it really makes that transition easier because it's going to slap your wrist if you try to do something else. So it looks like we got some questions here.
It's the bottom there.
From Derek. Could a pattern match be compared to a C# switch statement, but that requires a default? Meaning, when you were showing the maybe option, you had to specify how to handle both some and none. Yeah, that's exactly correct. It's very similar to a switch statement, but it's like a super switch statement. And here's why I say that. Let's see. Get to an example. Right. So here we have some and none. If this were a C# switch statement, we would have to we could do a switch, and then we could do a case none. But in this case, we're also not only matching on how that type was created. So remember once again that none and some here are just ways to create a record of this type, or a value of this type, I should say. In this case, we are providing then LOC, which is just a way of saying, if the record or if the type was created with her, then I know it had to have been created with some other value. And what I want to do is I want to pull that value out and assign it to this location here. This could be anything we want, right? The rest of my code here is going to fail because this name doesn't match how I'm accessing the value below it. And in this very specific or very trivial case here, we only have two different options for constructors. But you can imagine you could have loads of different options for option is kind of a bad way to say that because it's the option type. But you could have some, you could have none. In our either case, we saw that we had failure and success. Just two of these. We could say, you know, void would be a valid case, and in that case, we don't have to pass anything. We could have this. We could say my string of string, and everything is fine. But now you notice our code breaks everywhere now. So we're saying now, if either can also be created with all of these other things, you're going to start getting warnings all over the place. An example would be the value my string may indicate a case not covered because now you have my string here. So yes, it is similar to that. Just to continue this, that concept, if we were to bind to my string, we could have S here, and we could say S dot, and you would have all of the things that you would expect that the string object would have as extension methods or methods actually on the class, if that makes sense. So it's kind of like a switch statement on steroids, or pumped up, or I don't know, on steroids is probably a bad thing. On leafy green vegetables. Coconut oil. Coconut oil is great for everything. So I hear. Questions?
I've got one for you.
Yeah.
So do you have to use the match with expression with discriminate unions, or can you use that with like integers?
You can use it with integers as well.
Okay.
So in that case, obviously, you're not going to be able to provide whatever, you know, all the different cases. So the question is, so could I do match one with one, you know, I don't know, do something. The thing is, it's going to be really, really hard to, and do something's not found. Here, let's just return unit in the case. Like, we're never going to be able to provide all of them. So we're saying that to call into this match with, you can accept an integer. We're never going to provide an exhaustive match for integers. So we could do this default case, which is kind of like the default within within C#. But within F#, it can know whether or not you've exhaustively pattern matched all of the possibilities. So you see here, I didn't have to provide a default case for this either. It knew that it could only be either a failure or a success, which is where the either comes from. It's either a failure or a success. Any other questions in the group? No? All right. So let me show just a few things here. Hopefully I've not lost everyone. But even if I have, as I said, it's going to be impossible for me to teach you how to do all of this stuff in an hour. So the takeaways, really, I'm hoping, is much more why you would want to start writing functions that were very true in what their definition is. And going back to our domain and codomain thing, if you think about writing methods or functions, even if you can't write F# and you're writing C#, you can do the same kind of thing with C#. About the signatures of your method or your methods or your functions in this way, you're going to be able to combine all your code together much easier. So some additional resources for getting started. F# for Fun and Profit is just an incredible resource. It's how I really got started learning all of this stuff. I tried to learn F# maybe 2 or 3 times, and kind of never really got there. I never got to that, why should I learn it? It was always, hey, great, I can write the same app in F# that I could write in C#. Why would I want to bother learning some whole new syntax from a language that has, you know, nowhere near the user base? And as it turns out, it ends up being really, really powerful to learn it. And this site has a lot of really good things with getting started to kind of show you some of those things. We'll definitely hit on the stuff of a language's defaults matter and things like that. Reid Evans Tech is my blog. I've got some stuff on here. Domain, building some functional apps and some of that stuff. You can follow me on Twitter. I'm at Reid Evans. You can follow our group, which is at FunctionalKnox, which I actually don't have on here. And then all the code that I showed here is actually on this Getting Started with FP and F# at this GitHub location. And if you were to go there, you'll see here on the tags, you'll see that I've got the different tags. So that's just how I was navigating between the code. Some of the stuff matters, some of the stuff doesn't, but you could definitely look through all of this if you were interested in finding more. The vast majority of what we had was in this program.fs. And so you see, I showed a lot of code, and I went back and forth a lot, and maybe it was seeming like we watched and looked at a lot of code. But if you look, we only have 174 lines of code, and that was including writing our model binder and duplicating this create location function here just to be able to see it in both ways. So, and I've got copious white space here that's for sure not necessary to be able to do this. So code also has the web server where we're dealing with 404s and stuff like that. It also is hosting all my slides, which are actually just static pages within this framework. This is it. There's no additional config file. There's no additional all sorts of other stuff. It's actually very few lines of code to be able to do some of this. So if there's not any more questions, I guess that's it. Thank you all so much. Definitely shoot me a message on Twitter if you do have any questions. I would love to help out. And maybe help you learn some if I can. Probably I'm going to learn more from trying to figure out how than I will deliver value to you, which is what typically happens. So anyway, thank you very much. I will say we do have, and I'll let Cameron do this, we've got some giveaways thanks to Derek. Definitely not me. I'm not well connected enough to have giveaways, but Derek does. And so... Okay. Do we know how many people we have in here? Let's see.
Got 7 viewers online.
Oh, okay. And we also have another question on, can you touch on using F# together with C#? Is that even an option? It is absolutely an option. So it's .NET Framework. So F# will compile to C#. You can absolutely use it together. In fact, I've done that frequently. So let's see. I'm going to, oh man, can I do that? Actually, I can't show that project. Not a
So correct me if I'm wrong, but to mix F# and C#, you can't have it in the same project,
right?
Have it in the same solution.
Right. So what I could do, if we were to go into our solution here, which is I could easily go right here and add a new project, assuming I have C# installed on this computer. C# in the other languages section. If anyone from the F# Foundation is watching, they will find that very humorous that it is in the other languages and F# is highlighted. You could absolutely add another console application or a class library or whatever from C#. So let's just do that. And then within our references, we could add a reference, and within our projects, we could reference locations. And then within our class here, we could pull, we pull in whatever that should deal with that. So that's absolutely possible. One thing I will say about doing that is that there are features that F# has that C# doesn't have. So we saw some of those, one being the type providers, the other being this concept of a sum type, failure or a success. So your mileage may vary with calling, just because the languages do have some different features. One of the neat things, though, is that because I have this either of T and I'm providing helper functions for how to deal with this rather than the whole doing the pattern matching, you would actually be able to say either of, but deal with either is by mapping and binding. You would computation expression without calling it from F#. So you wouldn't be able to do things like this. Async, you would obviously then, you actually, one thing I will show is if you're doing that, we say async dot, there's a await task, which would then turn this, switch this up from returning which blocks. There's a schedule as task, or so there's an as task that you can do that will actually convert specifically so that the interop between C# and F# is better. You can absolutely do that, and one of the ways that a lot of people like to use F#, or a way that you could use F# very easily within your existing C# application would be here we have a type of location which, to be able to get every of these properties, has to be defined. So if we said like Knoxville, which is where we are, we would have to say ID, we'd have to provide some value for ID. So you see, we still can't create this because it tells us that we didn't assign something for the field of state. So if you end up writing a lot of C# classes, and just so that we're here, we'll say state equal TN, and now it knows that this is a valid location because these properties match to the only thing we have in scope that have them, which is this location. We do a lot of things like public class, foo, because that's what all classes are named, and you do something like read-only bar, read-only string bar, and public foo string bar. Or anything of the sort, and then some sort of public like read-only setter. You know, if you end up writing a bunch of code like this, I mean, that exact same code in F#, you could easily do you know, like that. And further, it's going to also then give you pretty printing, and it's going to override equality by default. So all of the things that we had to do here, you could get for free here by just creating a like a class library in F#, defining some types like this, and then using them from C#. It would be trivial to do that. Any other?
So.
You can pick a name from this list of going. Can't do that. He sent me a link over here.
Yeah, to the Windsor group. Look it up. So we're taking one from the Windsor group and one from FunctionalKnox.
Yeah, we can do that. So what are we giving away here? Hold on, I'm getting there. I can't even technology. Okay, so Telerik, a 1-year subscription platform. So, yeah, how many do we have? How many do we have in there? Yeah, so he's got it in the live chat. It's weird watching me from like 30 seconds ago on this YouTube. So, I'm not sure where Derek sent me the link.
To the meetup page? He had the Twitter sphere.
No.
No.
I sent it on Twitter.
Yeah, I'll say just tweet at you, not direct message. That's all right. I got it.
You got it?
I got that pulled up. That's what he sent to you.
Oh, okay. So let's get it to go.
You need a random number.
So 30. Yeah, we need a random number from 1 to 13, or 0 to 12. 10.
7, 8, 9, 10.
It looks like Nick Steele is the lucky winner. Let's give us another one. Let's give another one over there to the Windsor group.
Okay.
And do you want to tell her? Yeah. Yeah.
Great.
Number 8.
Probably going to butcher the last name here, but Sean, what do you think, Reid?
Sean D. So I guess get with Derek. He's got the stuff on that, and you should be good for that. Just a reminder, so next month, which March 7th, thank you. On March 7th, same time, 6:30 Eastern time, Derek's going to give a talk as well, so you all will see him in person, and then we'll be the ones on remote. So that should work. Derek's also saying in the meetup here that he'll send the license to you all on the meetup page. So with that, looks like we'll see some of you all or listen to some of you all or something about a month from now. And I hope you enjoyed it. Any questions, let us know. Thank you.
All right, thanks.